The objective for the Lesson 7 notes is to identify similar figures using corresponding angles and sides. So before we get into that actual objective, we'll go ahead and review congruence and similarity in this first activity. And if you read the directions, it says choose whether each of the statements is true in all cases, in some cases, or in no cases. So before we look at this activity further, I'd like to review what congruence and similarity mean. This activity might look familiar. It's from Lesson 6. You guys were asked to map one triangle onto the other. And if you recall, it was at this time that we said, let's go ahead and review the rigid transformations that establish congruence. And if you recall those three, we've dealt with them a lot. Again, these establish congruence. Those are rotations, translations, and reflections. And we use translation primarily in this example. No reflection, no rotation was needed. But now we broaden that scope and we say that we can just reference not only these three transformations as just transformations, but we can go ahead and include dilation to describe not keeping the shape rigid and keeping the size the same, but actually going beyond these basic three moves and then changing the shape proportionally as well. And now with this other transformation of dilation, we establish similarity. So with this brief recap of Lesson 6, let's go ahead and take a look at Lesson 7 notes. In this first example, we're asked if two figures are congruent, then they are similar. So to be congruent, if you recall, we have rotation, we have reflection, and we have translation. It was from these three transformations that we then also included dilation to establish similarity. So because these three transformations are congruent, then they will always establish similarity. However, if you look at the other way around, similarity is not only these three transformations, but we also include dilations. And it's the dilations that make things not congruent. So we could have similar figures because of dilation, of scaling a figure, but then they wouldn't be the same size, and so they wouldn't be the same size and shape, which is what congruent means. And so that instance is sometimes true. And then for the last part here, a little bit different thinking. If an angle is dilated with the center of dilation at its vertex, so here's an angle and here's the center of dilation, it's asking that the angle measure may change. But if we were to dilate a point, for example, that's on one of the sides of the angles, that point would just continue on that side of the angle as would the other. And that's never going to change the side. Let's say this is a 30-degree angle. Just changing the length of the sides of the angle, for example, are not going to change its size. So the angle measure will never change. And so this is going to be a never answer. After you feel comfortable with those three statements, let's go ahead and look at the 7.2 activity. Taking a look at the 7.2 activity, are they similar? Let's look at a square and a rhombus. Priya says these polygons are similar because their side lengths are the same, which they are. We have 2 and 2 all the way around the figures. Claire says these polygons are not similar because the angles are different. And so who do you agree with, Priya or Claire? Explain your reasoning. And so to be similar, we do need to note two things. We need to note that corresponding angles are equal. They do not change between similar figures. We also need to note that side lengths need to be proportional, which means that if I set up a ratio of sides, then I can get a scale factor that is consistent between both sets of figures. And so the sides proportional is what Priya's hitting on. She's saying that I can take 2 divided by 2, for example, on the square and get 1. I can take 2 divided by 2 on the rhombus, for example, and get 1. You can clearly see the sides are the same. But the angles are inconsistent. On the left figure, I have right angles. On the right figure, I have 60 and 120 at alternating angles in the rhombus. And so we are going to agree with Claire and note that they cannot be similar, the figures. So square and rhombus are not similar. Because the angles are not congruent. And again, similarity keeps angles the same, but it changes sides proportionally based on that scale factor we've worked with in dilations. When you're ready, go ahead and resume the video. If you need to finish writing, pause it right here. In this example, we're going to look at rectangles ABCD and EFG. And if you take a look at the rectangles ABCD, we have 2x4. EFGH, we have a 4x6. Jada says these rectangles are similar because all of the side lengths differ by 2. And right away, that word differ should be a red flag because we never have ever looked at differences in sides. We've only looked at scale factors. So right away, we're going to say we do not agree with Jada on this problem. Looking at Lynn's explanation, she says that these rectangles are similar. She says that you can dilate AD, which is 2, and BC, which is also 2 by 2, to map to EF and FG. I'm sorry, EH and FG. And then she says that you can take the side lengths of AB and CD, which are 4, and scale that by 1.5 to make the triangle or the rectangle on the left map to the rectangle on the right. But to be similar, these ratios need to be consistent. And because we have 2 different ratios of corresponding sides, we will also disagree with Lynn on this one. And so to reiterate what we addressed in the previous example, even though, so I'm going to make a note, even though the angles are congruent, even though the angles, you would either need to look at the ratio of sides in a figure or between corresponding parts to then compare that other aspect of similarity now, which is sides are proportional. So if you take 4 divided by 2, for example, in ABCD, and that's equal to 2, that does not equal, so does not equal with a slash, EFGH's ratio of sides, which is 6 to 4, and that's equal to 1.5. So again, the sides and the scale that you get from the sides not being equal says that these 2 figures are not similar. The other way to look at this, and the more precise way to look at this, is to actually set up a ratio where you're comparing ABCD to EFGH in one fraction. And actually, I'm going to flip those. I'm going to put EFGH up top because that's what we're moving toward, and ABCD in the bottom. And if I look at EFGH and the side length of 4, that corresponds to the side length of 2 in ABCD. And so that ratio equals 2 for the scale factor that Lim was saying she had. But then if I look at the side length of 6 in EFGH, that divided by a corresponding side length of 4 is what doesn't match up as well in terms of the corresponding sides not being proportional. Looking at activity 7.3, it says to find someone similar. But since I am out of the classroom today, we're going to go ahead and complete a matching activity at the end of the notes. So we'll continue to the Are You Ready for More? And then when we complete this side of the notes, you'll go to the substitute and collect the matching activity. For the Are You Ready for More? On the left is an equilateral triangle where dashed lines have been added showing how you can partition or separate the equilateral triangle into similar triangles. Similar triangles because the sides are proportional and the angles are the same. Find a way to do this for the figure on the right, partitioning it into smaller pieces, which are each similar to the original shape. What's the fewest number of pieces you can use, and what's the most? What we want to do here is look at keeping the shape the same but altering the size. So if you look at how long it is along the base here, that's an 8 by 8 square with this top right chunk taken out. And so let's start with just a scale of a half. What would that do? And so I'm going to go ahead and treat this like a dilation, and I'm going to dilate it from the bottom left corner, and I'm going to cut the sides in half, so that would create a 4 by 4 square, but I'm not going to include that top right chunk, and so I get this shape that I've just drawn, this partition. And then if I reflect that shape horizontally along the top side, I would get a shape that completes the top part of the figure as so. And then if I complete the shape around the corner, I get this partition. And so I've just created 1, 2, 3, 4 partitions from the original figure. And that's the fewest number of pieces that we can use. 4 pieces is the fewest number, and that's with a scale factor of 1/2. In terms of the most, I can keep having each of these shapes. And so instead of a 4 by 4 shape in the bottom left-hand corner, I'm going to go ahead and show I could partition this into a 2 by 2 with the top right corner of the square chunked out, and proceed through the diagram partitioning by a scale factor of 1/4. And then once I do the 1/4, I can do a half of that again and do 1/8. And so in terms of the most, there is no upper limit to the number of partitions we can create. To summarize the lesson 7 concepts, two polygons are similar if all pairs of corresponding angles have the same measure, and if corresponding sides are related by a single scale factor, meaning that you can multiply the scale factor to one side to get the corresponding side length in the other. And so if you take a look at A, B, C, D, and E, F, G, H in the diagram, and then you look at the work that's below, they compare AB to EF because those two sides are corresponding, and that creates a ratio of 3 to 4. Then if you compare AD to EH, which are also corresponding, and I'll go ahead and highlight that in a different color, so AD to EH, you do get a different ratio of 2 to 3. And because those ratios, that scale is not the same, then you cannot say that they are similar. In the example just below, you have two quadrilaterals with the same side lengths, but I'm hoping you guys see that the angles are different. So you must satisfy that both the angles are the same, and then unlike congruence, which said that the sides had to be the same, our sides now just need to be proportional. And so it's at this time that I'd ask you check in with the sub, you hang on to your notes, grab the matching activity to see if you can establish which quadrilaterals and figures are similar to each other.